Okay, so this lesson is on volume of spheres. Okay, so a reminder that volume is the amount of three-dimensional space an object occupies. In other words, how many unit cubes fit inside of the shape. Okay, for spheres, the volume is equal to 4/3 pi r cubed. Now we did surface area before of spheres, and that was 4 pi r squared. So we're looking at the volume today, 4/3 pi r cubed. And cubed is, just make sure you put that in. It's easy to accidentally do squared. Okay, find the volume of each sphere or hemisphere. Reminder that a hemisphere is just half a sphere. So we're just going to apply that formula, and then it's just a lot of calculator work. So let's give it a try here. Volume is equal to 4/3 times pi. Let's do this. There we go. Pi, and then times 7 cubed. Now you can just type that into your calculator just like that. You might want to put the 4/3 in parentheses when you do this, but you could just type that into your calculator. And when you do that, you get 1,436.76. And again, this is volume, so we're talking about cubic units. So this would be cubic inches. Okay, let's try another one. So this one, same, right? Except, we don't have the radius, we have the diameter. So I just need to say, all right, my radius, then what is this? Well, this is 16.5 halfway across. So just take 33 and cut that in half. So my radius, 16.5. And now I can just use that same formula. Pi times 16.5 cubed. And then I'm just going to type that into my calculator. Okay, and then when I do that, I get 18,816.57 cubic centimeters. So pretty big, a lot of cubic centimeters in that sphere. Okay. The last one here is a hemisphere. So you're just going to do the same thing that you normally do, get your answer, and then just cut it in half. So, because we're finding volume, so it's just half of that. And so here they give us that the diameter is 12.2. So that means, right, our radius is going to be half of that, 6.1. Okay, so let's just start by doing this. Okay. All right. So you're just going to type that into your calculator. Let me just do that here. Okay, and you get about 950.78. You're going to cut that in half because we want only half of the volume. Okay, so, and this is in also cubic centimeters. And that's really it for spheres and hemispheres. Pretty simple formula to use. Okay, so let's take a look at a composite shape. Assuming all the space is used in this shape here, find the maximum amount of grain the silo can hold. So here's a silo. that is 45 feet tall. We can see that we have a hemisphere on top of a cylinder. And the hemisphere has a diameter of 11 feet, which means the radius, a diameter of 22, which means the radius is 11, right? Okay. Then that also means, let's see, so from here to here would be 11, which means then from the cylinder is 34 if the whole thing is 45. Okay. All right, so now I want to use that to just kind of figure out each piece. So let's do the hemisphere first. So I say 4/3 pi times 11 cubed. I'm going to get my answer, and then I'm going to cut that in half. So really I'm just going to do that and then divide it by 2. Okay, so if I do that, let's see what we get here. It's like 2787.64. Okay. Now, let's try the other one. So cylinder is the area of the base, which is pi r squared times the height. And in this case, that cylinder is 34 inches tall. So if we do that, we get like 12,924.51. I'm going to add these two together then. Okay. Okay, so this silo can hold a maximum of 15,712.15 cubic feet. So a lot of grain can be held in that silo. All right. Hopefully that makes sense. You can go ahead and work on this assignment. Don't forget to write it in your planner. Good luck. See you later. Bye.